Welcome back to the Datarekha audio guide. I'm Diya.
And I'm Arjun. Here's something that sounds almost deflating once you hear it. The language model by itself is not an agent. Nothing about it is. The agent is the code wrapped around it. And today we build that code from scratch.
Deflating is right. So what's actually missing from the model itself?
Memory and the ability to act. A model is a pure function. Text in, text out. Send it a message. It answers. Send the exact same message again. It answers identically, with zero memory that the first call ever happened. It can't recall what it did 2 steps ago, and it can't do anything in the world.
So if it forgets everything between calls, who's doing the remembering?
The harness. That's the engineering word for the scaffolding that drives and monitors a system. If you want the model to remember what happened earlier, the harness has to stuff that history back into the prompt. If you want it to call a tool and then reason about the result, the harness runs the tool and appends the result. Without that, every API call is an island. And you've got a chatbot, not an agent.
Give me the heart of it. What's the actual loop?
Genuinely simple. While not done, call the model with the current context. If the response is a tool call, run the tool and append the response and its result back onto the context. Otherwise, it's the final answer. Return it. That's it. That's not pseudocode for the hard part. That's the entire structural idea.
And the named version of that? Think, act, observe. Maps straight onto one trip through the loop?
One iteration exactly. The model thinks, generates a response. The harness acts, runs the tool. The model observes. The result gets appended for the next call. Same 3 beats. One loop. Now that bare loop runs. But it's dangerously naive. A real harness needs 6 components. And that's where the whole engineering budget goes.
6. Let's go. What's the first thing the bare loop is missing?
Tool dispatch with schema validation. The model asks for a tool by name and hands you arguments as gesso. Before you call anything, you check those arguments against the tool's declared schema. If they're wrong, you return a clean, well-formed error back to the model so it can retry, not a raw Python traceback.
Does that really happen though? Do models actually botch the arguments?
Regularly, especially in edge cases. And without validation, it cascades. The malformed argument flows into the tool. The tool throws. The harness panics. The whole run dies. Catch it at the door, and the model just self-corrects from the error message.
What's next?
Context management. Windows are finite, and a naive harness that appends every observation forever will overflow. So you keep only the last n messages, a sliding window. Or you periodically ask the model to summarize the old history and replace it with the summary, compaction. Or you store old observations externally and retrieve the relevant bits by similarity.
There's got to be a cost to throwing history away though.
Always the same trade. Memory versus fidelity. A tighter window is cheaper and faster. But the model might forget an earlier observation it actually needed. There's no free lunch. You're choosing where to spend.
4th?
Permissions and sandboxing. And this one's the security boundary, so it matters most. Tools do real things. Write files, call APIs, send emails. The harness is the last line of defense before any of that happens. It keeps an allow list of which tool and argument combinations are permitted, and it can require human confirmation before anything irreversible.
Wait. Why can't the model just police its own permissions?
Because the model can only request actions. It can't enforce anything. The harness is the only component running with real system credentials. So if the model gets prompted by a user or by an adversarial document to call a destructive tool, the harness either stops it or it happens. There is no third option. You build that check before you deploy. Not after the first incident.
Okay, 5th and 6th. And then I have a question that's been building.
5th, stop conditions. runaway guards. A loop with no stop condition runs forever, burning tokens and producing nothing. So, a max steps cap, a max token budget, repetition detection. If it calls the same tool with the same arguments twice in a row, it's stuck. And a wall clock timeout. And you trip the cheapest guard first. Token counting is free. Repetition is a dictionary lookup. So those fire before an expensive final model call.
And the sixth.
Verification. Not every loop should just stop at the models first. I'm done. For tasks where correctness really matters. Running code, structured extraction, multi-step math. The harness runs a check after the model declares it's finished. Execute the code and confirm it doesn't throw. Pass the output against a schema. It costs one extra model call, and it catches a real fraction of hallucinated final answers.
Here's my question. If frameworks like LangGraph already exist, why hand-build any of this?
Because, and this is the payoff, those frameworks are this. Strip back LangGraph and you find this same while loop, this same dispatch table, these same stop conditions. LangGraph makes the context an explicit typed state dict and the loop an explicit graph. Another framework adds a message bus and middleware. A third adds cloud deployment. But the skeleton is identical.
So once you build the harness yourself, picking a framework stops being a conceptual decision.
It becomes a syntax question, not a concept question. And there's a clean way to remember the 6. Each one maps to a specific production failure. No context management, you overflow. No schema validation, tracebacks poison the context. No repetition detection, it loops forever. No max steps cap. A stuck agent hits 1,000 steps and costs real money. No permissions. It calls destructive tools unchecked. No verification. Hallucinated answers sail through as correct.
One sentence to carry out.
The model is just a stateless text function. The loop, the tools, the context, the permissions, the guards, and the verification around it are what make it an agent. And they're the entire reason it works or breaks.
The model's the engine, the harness is the whole car. That's the Datarekha audio guide. See you in the next one.